Hello everybody, good day to you. Welcome back. Glad you guys are here. I'm here. I'm super glad to be here. Dave's over there. Dave, you glad to be here? Dave's glad to be here. People were mad at me. I threw a can of brake clean at him yesterday. Oh no, I'm running out of brake clean. Dave, another! And they're like, ah, he's gonna quit. Dave, you mad at that can of brake clean I threw at you yesterday? No. Yeah, see, well, I didn't throw it at him, I just threw it under the car. Yeah, it just went under the car. Yeah, no, it's all good. Got CP's garage here. He's working on a Ford F-150. It's got the, what is it, the 3-liter?
3-liter power stroke.
I'm not gonna show you what happened because I'm saving that for something else, but it blew up and died. We'll see that one later on. I'll tell you guys when the videos are gonna appear on this one. It's gonna be good stuff. I think we're gonna involve I Do Cars for the engine teardown on this thing. We're gonna be pulling the motor out. Today's Diag day on that one. What we're doing today is returning to our Honda CR-V, and I'm trying to figure out what happened here. See, I walked in shortly thereafter. I received a delivery for this thermostat right here. And then I look over on my bench and I have another thermostat right here, which is odd because I only ordered one thermostat, but I ended up with two. And of course we have the housing. This is the primary cause of the blue coolant leak on our blue Honda CR-V. In the previous video on this car from yesterday, we were digging around on the back side of the cylinder head to replace the VVT solenoid pack due to a leaking gasket and oil flowing everywhere. We also changed out the oil pressure sending switch right here because I could not determine if this was not leaking or if this was leaking as well. And since it is right there in the same general area and it's a cheap kind of part, we just ended up replacing this as well. This may not have been a leaker, but it also may very well have been a leaker. And I didn't want to send it out after doing an oil leak repair only to find another oil leak in the same location, because that is a customer perceived comeback and we're not trying to do those kinds of things. Anyway, in this video, we're gonna move on to the cooling system repair on this. It sat overnight on the lift and it's been leaking coolant everywhere again, primarily from that thermostat housing down below on the bottom side of the engine. So we're gonna get this thing back up in the air one more time. We're gonna get the cooling system drained out. We're gonna change out that thermostat and the housing, refill it, and if we have enough time, we're gonna do a little bit of work on this electrical situation over here with this this radiator fan assembly. It's got a bunch of caulk on it, a relay, some wires, some kind of thermostatic switch. There's a thermostat right here running down over there, and all that's plugging into the fan. So our guy would like us to rectify that situation and try to put it back to stock. But in order to put that back, we need to find out what happened and why the cooling system had failed. But that's gonna have to wait till the end of the video because we need to get that leak sealed up. So stay tuned because this is gonna be a very good video. Moving on up, opening the hood.
Oh, look who that guy is.
Okie dokes, CR-V's up in the air and we're gonna be looking right in here at that thermostat housing. All right, let's get some light on the subject and we can see, we'll revisit the leak. We see that that moist saturation right there at the bottom of the housing. What we need to do is drain the system, take the thermostat off, take the hose off, and then disconnect that hose back over there. Then we can unbolt this housing from the side of the engine block and then remove the unit. So that's what we're gonna be focusing on today. First things first, let's get the coolant drained out of it. And fortunately for me, this radiator happens to have a petcock valve right here, conveniently located, unclick, conveniently located right here. Open that guy up and just drain it right on out. Let the blue flow. Alrighty, while we're draining, I'm gonna get my mitts in there and get started here. I guess first things first, we're gonna lose this clamp up here on this radiator hose. Trying to maneuver past the dripping coolant. That's not working. Maybe I just need to be patient and wait a minute and wait for this drain to stop. Patience is a virtue, and I may be less than virtuous today. Come on now, clamp, get out of there. There we go, got her. So now let's go ahead and peel back this this upper hose, or lower hose rather, and accelerate our drain action. Is it gonna come off? It's reluctant. I'm getting splashed. I'm gonna pull it back slightly. I don't wanna go full send on the coolant dump here. Ah, yep, went full send on it. Not what I wanted to do. There. Leave that alone for a little while and let it ride out. Get that out of there. Okay, I think we're good. It's about as much draining as we're gonna get until we crack these 10mm bolts loose. So let me go and fetch a ratchet and a 10mm socket, and we'll get those guys pulled off there to get the thermostat removed. All right, we need a little bit more illumination in there because I stick my paws in the hole here and then I don't have any light to see what I'm trying to see, which is not ideal. So we'll get these bolts removed right here. Now this housing appears to be silicone sealant in. It's got RTV around it. So I'm assuming that this thermostat was changed in order to stop the leak. But the problem is this part wasn't the leak. It's back here on the actual housing part. Let's get this guy unthreaded here. Might just, you know what? I'm going in there with an electric ratchet. This is gonna take too long. I can't like it. And let's try to speed this up a little bit. Hopefully we don't have a repeat on yesterday where I can get my paws all over the parts but I can't manipulate the fasteners. That would be annoying. Ah, look at here. See the that smooth shank right there? That is designed so you cannot over tighten the thermostat against the housing. This thing will bottom out on the bung in the housing and it won't get any tighter once it bottoms out. So there's only a certain amount of clamping force that's going to be allowed to be applied to this thermostat right here. Interesting. I was looking at the old design and I wondered how that was going to work out. Yeah, I was looking at the new components and I noticed that there was kind of a gap between these two because of the O-ring or the seal that was behind this thermostat, and it appeared that it made it or it was possible that the bolts would draw that in and actually flex this housing, but it appears that through the use of these bolts that's already been thought of and mitigated. Neutral drop. Now we're flowing and dropping fasteners. Here, maybe I'll come in from the top here and try to get a hold of that, that last bolt up there. We can't see it, but it's up there. Flashlight. Flashlight down, man down. Oh, almost. I can see it. I can't. Just can't really get to it. Yeah, we're doing the same thing we did yesterday with that solenoid pack. This is becoming frustrating instantly. Yeah, I've got an idea. We need to make some more working space after I break my flashlight. Stay right there. What I'm gonna do is disconnect this trans line right here. Pull that guy off. Set that aside. Maybe I got a little bit more wiggle room out of this. Shouldn't have done that either. Should have just taken this bracket off. That's okay. Set that aside. Maybe now I've got, yeah, I got a little bit more space here to play with. See if I can't get on that top fastener that's in there. There's an AC line in the way. I know, we need a swivel socket. That's what I'm gonna fetch. 10mm universal swivelly socket. Gotta love the wobbly bits. There we go. These guys. I don't break these out very often because I don't want to lose any of them. Is that my 10? Sure is. And we'll swap out the straight socket for this unit. And that should give us some decent purchase on that top fastener. Should. It better. It better should. Almost. I see you up there. Got to get the universal lined up. There's a wiring harness in the way. Come on now. Get on there. There we go. No. I'll break it loose by hand. Now let's try this. Two-handed operation. I'm gonna come in with the swivel, get that top bolt. My phone's ringing. I just got done with the distraction. I don't want another one. Oh, unclicks. That was tight. Super duper tight. Okay. Now that that's broken loose, go back in with the electric. All right, now maybe I can sneak this tool in here and spin this fastener out. Here we go. Now we're cooking. Uh-oh. Oh, it got caught on the magnet. There we go. Let's pull this guy out. Yeah, look at all that sealant in there. That's not how we do that. It's I mean, it's okay, but it's not necessary. I don't think they the rubber seal that's back here should always be sufficient to seal things, so we don't have to add sealant to a gasketed surface. It's not horrible, but it's not what we need to do. So we're gonna pull this guy out, get that out of the way, and we've got a couple more fasteners on the housing here. There's 1, 2 right there. There should be another one, yeah, right up here at the top. Then we've got this hose hanging out right here. Once I get that hose removed, we've got to wiggle this unit down from this pipe that runs up. I think that's like a bypass pipe. Oh, you can't see. Yeah, bypass pipe right there. That one slips into this housing and has an O-ring inside of it. So we need to get in here with some pliers and pull back our clamp on this hose. Gotta be super careful with this hose because I don't want to damage it. That would not be good for us in the long run here. Kind of give that a push. It's not gonna move. Twist it some. Here we are. It came off nice and easy like. Good. So let's get in here and pull the rest of these bolts out. 2 at the bottom. Cannot see. Yeah, that was highly ineffective. Tuck that up. Top this wiring harness here. Stay out of the way, please. Good. Let's try to get that top fastener out. She's right up here, way out of the line of sight. I can feel it, but I don't know if I can reach it. Remove intake manifold. I meant to do that. Ah, there's that bolt. The lubricity of the coolant is making this annoying for me. Yeah, I'm still not getting on it. I'm gonna switch to a straight socket in a second here. Or we're gonna do this just like this. Come on, come on. Yeah, this is giving me like flashbacks of that BVT solenoid. We're doing the same thing. I can reach the bolts, but I can't do anything with them. I can't like it. Let's try a straight socket approach. I pulled off the wobbly bit. Yeah, not much space. Again, no room for a power tool. This is all manual labor. Here we go. That one's tight too. Come on, unclickage. Yeah, we're moving now. I hope I don't find a bunch of sealant behind this this housing as well. That would be annoying. So I'll have to clean it off. Ah, there's a cut on my finger and the coolant is making it burn. Oh no. Okay, let's do the tool change out here. A shorter ratcheting tool here. I figure it'll give me more RPM on the fastener since I can't use electricity to generate my rotational forces. I'll have to just use the properties of leverage. There we go. Now we're cooking. Got some speed, more steam. Come on, baby, let's go. Almost there. I think that's almost enough. Can I? Yep, I'll work it out with the flanges. No, I won't. We're about to bottom the tool out against the starter right here. See that? Don't want to get it wedged and stuck, so I'm hoping I'm almost out of threads here. Oh, carpal tunnel on the way in. There we go. There's the fastener. 3 down, 4 down, 5 down, 1 to go. Uno mas. And I'm going to switch back to my wobbly with an extension. We're just going to go in at this angle here and spin that last one out. Longer extension. Okay, let's get in here. Wobbly bit and an extension one more time. Cracker loose. There we go. That was easy. So now we just get a hold of this guy here. We're gonna pull it back. Yeah, it's siliconed on. There's sealant in there. Feels like it's glued in. And we've got to wiggle it off of that pipe, that bypass pipe that's running up. So we've got to pull her down and kind of just maneuver it till she comes out. Like so. Oh, look at that. It's nasty O-ring up there. And it's a flattened O-ring. That's not good. That might have been the leak the whole time. Yeah, there's that sealant again. See, this is why we don't need this. See how that sealant kind of made its way into this cooling passage? That's not good, because this can break off and end up circulating around. It's not the end of the world, but if you can avoid doing that, that's probably for the best. Let's go in there. I'll use the abrasive properties of a towel to scrape off whatever is left over. And if I really got to get in there, I'll get a scraper or a razor blade, which I think I might. This is why I don't like to use sealant in places like this, because the next guy has got to clean it off. Yeah, that's caked on pretty good. I need a scraper for that. Scraper. Carbide tip scraper coming in. Just gonna drag this along the surface. We'll peel away all that RTV.
Let's do that.
It's getting more shinier.
That's better. Very nice. Okay, another towel coming in. We'll get the smaller bits removed. This should peel those off with just some friction. Okay, good to go.
Now I need to figure out what to do about this O-ring right here, because I know that that is not going to seal in the long term. Okay, kind of a risky move. I'm gonna pull this O-ring out and try to match it up. The risk is if I can't match it up, we are dead in the water on this. I'll have to figure out how to source this O-ring. So I'm hoping I don't tear it to pieces. There she is. Okay. Hope you guys saw that. Anyway, I got the O-ring off. I'm gonna go try to match this up. I've grabbed one from the kit that I think is close, but it's probably not gonna be wide enough. But I'm gonna fit it onto the hose and see what happens here. Okay, well, I had to go down to the parts store and get the proper O-ring for this right here. The ones out of the generic kit were not sized properly, so we had to just go get the actual O-ring, which was annoying because you'd figure that the housing would come with the O-ring that is needed, but it doesn't. This O-ring is it's not visible right now. This O-ring is not part of the housing, it's actually part of the tube, so you only get it unless you buy the tube or get it separately. The parts packing people were not very intuitive with that idea. There we go. O-ring's installed. Let's go and fetch the new housing. See, it's over here on the box, or the bench, or the bench box. Housing. Where are you? No. Oh, right in front of me. There it is. Yeah, you'd figure that these housings would have that O-ring inside the box, but they do not. That's like saying that you don't get this seal because it should be part of the engine. I don't comprende. It's a $2 part. I would happily pay $2 more for this, but no matter. Anyway, I'm gonna throw some dielectric lube on that seal right there so it doesn't get bound up and pinched when I go to do the install, and then we'll get this this housing assembly in position. All right, coming in with some little bit of lubricity here. I don't need to squeeze any out because it's been slowly oozing out of the bottle since the last time I used this. Give that a generous coating of lubricant. Get some on the back side there. There we go. Good. So now we shall maneuver the housing in position, focusing primarily on that tube. What am I doing? It's pointing the wrong way. Just kind of wiggle that in. There we go. That's in position. Now we just need to bolt the housing to the engine, and then we'll get that hose right there reinstalled. Okay, fasteners coming in. These are smooth shanked fasteners, just like the ones that go on the thermostat. Get that bottom one in right there. Start with this one. Yeah, here's a better illustration of what I was talking about. So if we hold this up to the plastic on the housing, we can see that it cannot crush the housing due to that shank being smooth. That's the nature of the design. So you really can't use a conventional bolt unless you're super vigilant on not over torquing these things, which it would kind of be hard to do. It's sort of like a hand stuck foolproof method here. Let's get one started and then we'll get the others lined up and in position. Gonna go in. There we go. I cannot see. There, now I can see. Taking care to not cross thread this in because it's at a weird angle right now due to that gasket surface pushing this away from the engine block. So what I'll do is come in with the extension and the wobble, kind of run this down a little bit. I didn't get much thread engagement. It was getting tight due to the friction. Yep, going in nice and smooth. That's It's about halfway in, so let's get the other 2 bolts in next before applying any other forms of torque here. Pardon my, my flanges. Can't, definitely having a tight squeeze kind of moment here. Super close quarters combat. Come on down. No. Yeah, getting this to line up is proving challenging. I'm disliking what's happening here. That gasket is very thick in comparison to its compressed height, and that extra space is making this less than ideal. Yeah, I've got to pull the housing down some. This isn't right. It's not working out. This is exactly how that VVT solenoid went. I don't like this. See, I can get it lined up if I pull, but I can't maintain that downward pressure and still attempt to thread that thing in. Tell you what, I'm gonna put some more torque on this fastener right here, the one that's already in position. I'm gonna run that down farther, and it's gonna start to compress the gasket on the back side and draw that in a little bit to tighten up the tolerances. You see that gap closing up right there? So we're kind of getting this in position a little bit. It's not tight yet, so I should have some amount of wiggle room here to be able to move this around. Yeah, that's a little better looking. Let's get this other fastener in here, bolt. Still not there, no. Yeah, I've got an idea. It's a rather unconventional idea, but it'll work because I'm going to employ the use of pry bar. So what I'll do is I'm going to put this other bolt in the top right here, and I'm going to use a pry bar. What was that? Something fell. Oh, my bolt fell. I'm going to put this in right here, and I'm going to pry bar against this bolt and push this housing this way, and it should pivot off of this fastener here, bringing that hole in line with the threads on the back of the engine. That's the idea. I don't know if it's gonna work, but it's the idea. I fix cooling systems with pry bars. Because why not? Why not pry bar your cooling system components? Yeah, ooh, that's good too, right against the AC line. Oh, look at that. Now we're getting somewhere. That's using the crane branium. It's better than cross-threading this, I say, because it's easy to cross-thread things. It's harder to do it the right way. But also, cross-thread is like nature's own Loctite. It's built in. Okay, coming in, extension and a 10 mil wobble yet again. I'm gonna put some torque on that guy and thread it down some, make sure it's all straight and good to go. But there's no space here, so I'm gonna have to add extensions to create a compound extension here. We need a super long one. Gotta get the proper angles here, and I need space to be able to turn the ratchet. Let's get that guy in. And the threads are going. Feeling good, nothing's binding or turning. I like what's happening here. And similar to that first bolt, I'm gonna run this down kind of tight. Not enough to start compressing the gasket, but just enough to take away any potential movement and slack out of this. And contact is there. Now for the hard one, way up top here. No. And I know we can't see that one. I can feel the hole right here. Get that guy in. I'm gonna attempt to thread this with the same extension configuration system that I've got going on here. I think I have the right angle on this. Yeah, we have contact. No, I don't. Oh, come on. I need a different socket. The offset is wrong. Here, let's try this one. It's a deeper swivel 10 mil, and that should kind of help bring the swivel portion away from the housing for proper angle and clearances. Let's try this right here. Just keep turning or slipping, slipping and turning and turning and slipping. There we go. Now we're configured, or not. We were almost configured appropriately. Come on. I'm striving to achieve some excellence here, and the nature of this design is preventing such things. There. All right, so when we bottom this one out, I'm gonna send it all the way to the bottom and apply full torque to this top fastener. Then we'll go around to the other two. Almost. Okay, I just saw the housing move, so it's applying clamping force. I'm applying torque, there we go. Torque achieved. Click. All right, that one's in. Let's move on to the next one down. That one's mostly tight. That one just needs some final torque applied here. Whoa! Oh man, caught you. You guys fell down. You were on a magnet, that's what happened. I wonder if I'm like a walking like anti-gravity magnetic field where my magnets just like slowly give out. There's gotta be a reason for that. Anyway, that one's tight. Last one, let's apply some torque here, and that's gonna finalize our clamp against the water pump housing / engine block. Clickage. Housing is now installed. Let's move in a little closer here, and I've got to get gotta get my hand in there somehow. There's no space. Come here, flashlight. We need to get this hose fitted over that nipple right there. Come here, hose nipple. Oh, come on now. Come on, no, it's going the wrong way. It's not what I want. I want it here. No. I know what we need here. We're gonna grab some angular needle nose pliers. These ones, curvy angular needle nose pliers. I'm thinking I'll get a hold of it like so, without poking a hole in it, because that's very easy to do with pliers like this. We'll just nudge that back down. I wonder if I can get the clamp with these pliers as well. That would be a feat. Hee hee hee. It's working. But not all the way. Okay. Conventional pliers are needed. You go there. Going back in. You see that pressure switch right there? I don't want to break that. Watch out for that. Just wiggle this thing down. All the way down. It's got to go back. Oh, not that far. And I screwed the pooch on this one. Okay, redo. Got to do it all again. See that? I just pulled the clamp off of the hose. Scheiße. I don't think I'll be able to slip it back on. Maybe. Oh yeah, sweet, got it. It's back on. That was fun. I didn't think I was going to be able to pull that off like that. I figured I was going to have to pull the hose back off, then remove the clamp, and then redo it. I'm glad that worked out. Okay, so let me fetch my installation bolt up here. Get that guy back out. And then we can get the thermostat reinstalled. What you looking at?
I have a question.
What is it? You're patiently waiting.
When Aaron,
for me or for all of us?
For you, mainly.
Okay.
But when Aaron is here on next week or
Yeah.
the week after, can I schedule some vehicles for you as well?
Absolutely.
Okay.
Okay, cut. All of a sudden we find ourselves with more technicians in the building than we do stalls in the building, which either means we need to roll cars in and out with more efficiency, or I need a bigger building. And I'd like a bigger building, so we're just going to start talking about that right now, and maybe we can manifest a bigger building for in the future. Now, let's get this thermostat in position here. Now again, similar situation. There's the top bolt, which I can barely get a hold of, and of course the ones on the bottom, which I can easily get a hold of. So we're going to put in the lower bolts since they're accessible, and we can use those to locate the component. And by locate, I mean hold it in its position where it's supposed to be. I know where it is, so I don't have to locate it in that context, but holding it in position is another form of location that can be used with the word. And I've just misplaced those two shanked bolts that I just had. Are they in here? Yes, they are. Stay. Gross. We did a diesel oil change in here. Now there's diesel oil in all of our stuff. Das is not good. Give that a wipey down. I'll undiesel it. These are pre-lubricated threads. That's what we've got. Is there sealant on that? Yeah, there's RTV on the shank of this fastener. See that? Hang on, I gotta scrape that off. Not gonna work. I know. I'll take this and put it on some needle noses, and then polish that off with a wire wheel. I was trying to pick it off by hand, but it's on there pretty good. I'll just wire wheel it away, and then it'll be nice and clean and smooth like. We'll get this one installed next. See, another reason to not use RTV on everything. It's fantastic stuff, but it doesn't need to go everywhere.
Oh, whoops!
There's a greasy rod in the vise.
Here, let me take it out.
No, it's fine. You can leave it there. Don't worry about it. All I gotta do is...
I gotta take it back out anyway, flip it around. I did this side already.
Oh, good. Yeah, I just need like 3 seconds on...
Oh, the wire wheel?
Yeah, that is all. Oh, Dave, will you have Lauren go get you an idler bracket? Have her order that? Yeah, I didn't order those two. Thank you. We're rebuilding the front end. Okay, now that we've unsealed the fastener, we can put that guy back in. One's going on the bottom side. Again, the shank will locate and align this component where it's supposed to be, making that top bolt easier to get in. Much easier. There we go. Ratchet coming in. Spin that down some. Contact. And one more to go, which is right in there hanging out. Give that a good wipey. And there's sealant on that one too. Okay. Repeat, back to the grinder. Let's see here. There we go. Pardon me, sir. One more time on the grinder unit here. Safety squints. I mean, I'm out of the line of fire too. There we go. All right. Last 10 millimeter. Gotta reach kind of up and over. Tuck that wire out of the way for some clearances. This is the hard one. Yeah. Oh, come on. Let's feel those threads catch. There we go. Almost. Nope, not yet. So close. No. Fail. Let's try it again with the right hand. Maybe my left-handed threading abilities are less than ideal for the situation here. Or we have an alignment issue. It's not aligned, yeah. It started. Here we go. Okay, got it. Threads are started. Let me sneak in with the ratchet again. See if I can't get those to run down some. Nice. Okay. Now although those are bottomed out, I do need to apply some actual torque to them because I did not get any kind of tightness achieved, and that those will back out if I don't make them a little bit tighter. I basically just bottomed them out. So we're switching out to the ratchet again. Let's get the right angle here. That's why I like these flex head ratchets. Okay, top fastener. A little bit more here. Leakage. That one's tight. That one feels good. That one's also tight. Okay. Now let's get our upper or lower hose back on. Right there's good. Let's get the clamp reseated. Not reseed, but reseated. Reseated. Back to this no space situation here. There's nothing worse than stuff that you're working on staring at you right in the face and you can't manipulate it. It's remarkably frustrating when that occurs. And this is definitely one of those types of situations where I'm staring at my problem in the face and I can't do anything about it. Now let's try this with some maybe longer needle noses. I can get more manipulation angle on these components here. It's gonna slip, maybe. Maybe not. Okay, now see what this did? That connector locked in. See how they've got those little locking tabs on it? Usually they don't like to set up like that, but this one did lock into position. So all I need to do is give that a, it's not gonna unlock, screwdriver. So what we'll do, I'll come in with this little flat-bladed screwdriver, get it between those two pieces and twist. Watch this. Now we're good. Except that clamp is not aligned with the witness marks on the hose. So I'm gonna rotate that and move that into its original position. So what we'll do, grab the other end of it there with the needle nose, give it a pull, and it should rotate around. Very slight pull. With some sparks. Ah, come on. Seriously? Here, I know. Get real simple with this. Watch. There. Problem solved. All right, so we're done up inside of this cavernous web of things that are in the way. Let's recover the illuminators. I need to put the mount on for this little transmission line filter business right here. We'll bolt that back on, then we can let her down and refill the coolant. I think that's the one. Now, this thing does not, or it has blue coolant in it. I don't regularly stock the blue dyed Asian coolant. I'm gonna use my BG coolant because it meets the specs for this Honda coolant. So that's what I'm gonna use. It's gold in color and it is not the same blue. So nobody get mad at me for using a gold coolant in lieu of a blue coolant because it meets the chemical makeup and the correct specifications. So I'm allowed to do that. Let's see here, let's get this guy tightened down a little bit. Ring, line it up, there's a little peg right there. That locates the bracket. Put that guy in. Then this thing is gonna sit right here on that bracket. It's a two-piece kind of unit. This side is gonna clip in, or slide in right there to that tab. Pull that down, and then it kind of clamps together. So we've got one more 10 milli. Let's get this guy started. I went too far. Whoa! You see that? I just moved through the matrix, bro. Like I dropped it and I broke the sound barrier catching it. That was fantastic. Anyway, I went too far. Let me back that guy out a little bit. And we're gonna push this filter. I think that's a filter. Cody, is this a filter?
Sure looks like one.
There we go. Pickage. Cool. And last but not least, I need to cut my zip tie off because that doesn't go there. Yeah, I stuck that little zip tie on to kind of keep the hose out of the way. Time for the cutters. Snip. Okay, that looks good. Everything's back together. Good, 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 good. Let's recover all the flashlights out of here and the magnetized items. We'll let this thing down and get her refilled. You guys stay there. All right, moving back around, up off the locks, lock release, CRV coming down, all the way down. All right, radiator cap coming off. The valve down below is also closed, and gold coolant coming in. I don't know if you can see the gold hue to it. It kind of looks like water. It's a lightly colored gold. And again, that's just the dye package. It 1000% meets the specs. Well, it can't be 1000% because I don't think you can have something greater than 100%, because anything greater than the original 100% becomes the new 100%, right? Ooh, here we go. Getting a little brave on it, pouring things. Oh, I almost lost it. I had to, there we go, I just dumped it, oops. See, I was fine until I stopped showing off. Anyways, we're refilled. I'm gonna go ahead and start the engine, get some coolant flowing through here. We need to let it come up to operating temperature. That way that thermostat opens and we get full flowage. We can fill this back up, cap it off, let it pressurize, and then we'll inspect for leaks. There you go. It's a full gallon too. All right, coming on around. Let's go on back inside of the cabin, restarting the engine. Good to go, she's alive. Let's make sure we're not dumping, that's negative. And I need to go and refill the bottle here. Refill. Oh no, you're good, no worries. Yeah, the machine already did, but I don't know what to do now. Thank you, Eddie. Yeah, of course. Refill complete. Full beans. Okay, let's finish our top off here. While we're adding fluids, I need to go ahead and throw a little bit of power steering in this as well. We noticed in the last video that the reservoir was slightly low. There we go. Glug, glug. Fill it on up. Now what'll happen is, too much. Too much. What's gonna happen is we're gonna notice that all this is gonna end up being totally blue in color. This coolant will accept the color of the current coolant and just dye this blue as well. So it'll slightly dilute the blue coloring, but not enough to make it unrecognizable. I think that's good. Yeah, we need to figure out what the situation is with this business right here too. I think that the fan stopped working and this was like an automatic temperature switch that was installed in lieu of whatever causes those fans to come on. And it obviously comes with a relay, it's got its own power and ground. And then I believe that this wire we were wondering about earlier that ran back here goes to a switch in the cabin in order to turn that fan on. I think that's what's happening with this the situation on this this fan relay wiring situation thing here going on. Words. We're gonna do some super long range immediate pouring. Oh, so close. I could probably use a funnel and not spill as much, but it's fine. Okay, the reservoir / overflow bottle is about halfway full. That's as far as we're going to fill that. We need to allow room for expansion. The system naturally will expand and push some of the coolant into that bottle. So we don't want it to expand, push coolant in, and then have it overflow through the bottle here. So we do leave a little bit of space. There's actually a full mark, usually on the side of these bottles. This one, I believe it's there's like a line right here. It's kind of tough to see from where we're at. There's a mark right there that shows the full level. Yep, see, look, it's blue again. Blue, not gold. That's tight, put that on. Where's my cap? What I'll do is give this upper hose a bit of a squeeze here, make sure there's no air in it. Just kind of squeezing, just a little bit. I think we're good. On there properly. There. Good to go. And since I did spill some coolant, we'll rinse that off with some blue water. Very nice. Okay, let's run this thing back up in the air. We can wash off all that residual spillage. I'll give that a little bit of a spray. And then we can pause and then monitor that for leaks in a moment. Moving back up. You getting cold?
looks like, yeah.
Hey, turn the heater on. I'm feeling it too. It's a little chilly.
Do I just turn?
Yeah, there's a orange switch on the other side. Yeah, just fire that up. Ah, full steam. Oh yeah. I like it. Oh yeah, I can feel it. Beautiful. All right, coming back in. We're gonna be focusing on this area right here. We need to make sure there's no leaks or drips. The valve is tight. Just spray off all that leftover nonsense. Wash that off. Very good. All right, we'll let this brake clean dry up some, and then we'll come back and revisit this area in a moment. Alrighty, 20 minutes later, and we are high and dry back here. There's no fluid at that O-ring, nothing around the thermostat, and the housing gasket right there in that position is also looking dry. This is good. I like what we've done here. Alrighty, coming down again. Let's take a quick peek into trying to diagnose what's going on with those cooling fans up there. And then we'll see what that system is going to need. That way we can remove and delete that aftermarket temporary repair that we saw going on with the relays and the thermostatic switch and the caulk and the wires and the switch inside of the cabin and all that other good stuff. All the way down, achieved. Steaming. What are we steaming from? This leftover, that light's dead. Na, 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 na. Where's my other light? Ah, there it is. I left it over here when I did the walk by. It's a very strong magnet. Come here. There. Okay. Yeah, no biggie. That's just leftover spillages. Things are heating up and steaming off. Okay. So the fans have not come on. Let's go check the temperature. We should be nearing operating temperature at this time, and there is no gauge. Okay, so let's try this. We'll turn the AC on. The AC should command the fans on. So we got our low speed. I don't know if that's the low speed or the high speed, but one fan is on. This fan over here is the one connected to all this business. So what we need to determine is why this connector here does not seem to have power. See the fan, that's the fan connector, plugs into the motor, and then it's gonna plug into that connector there, which goes into the vehicle's wiring harness somewhere. We need to see why that is not getting power, or theoretically why it's not getting power. Let's toss a multimeter on it real quick just to make sure that that fan is indeed not receiving a on command from its control module. So we are in, it's AC voltage, DC voltage. Let's go ahead and test out our meter real quick and make sure it is reading. Plug you in. And 14 volts. So the meter is functioning. Let's get this connector plugged in to our meter right there. That's the guy. I switched out the lead. The other one was a female lead. This is the male lead. But it's got the pokey bit. So we will take that connector, which also, according to the theme of this car, can't be reached, because I can't reach anything on this car. Probe one side of that connector, and then get the negative side. I'm looking at the meter right here, and I'm not seeing voltage coming up, so it's not powered. Double check all the connections. Yeah, we're getting millivolts out of it. Okay, nothing there. So we need to find out why we don't get power at that fan switch. We should be getting power because the AC is commanded on, which with the AC on, it should want both of those fans to fire up, and it's not doing that. I suppose we should see if I can make the fan turn on with this little thermostat switch right here too. Turn up the temperature. It's not doing anything either. There's nothing happening. Maybe the other way. Nope, still not on. It should be coming on, and it is not. Odd. Alright. So next, let's go ahead and just power the fan directly to make sure that the actual fan motor itself is going to run. I'm assuming it does, but I don't know. So we're just going to give it some power straight from the battery. We need to disconnect these little guys here. Both of those units. Plug that one in. That's the positive side. Negative is going to be this blue cable right here. See if the actual fan comes on. Yes, fan is running. So we know that fan actually does do its job. We'll leave that alone, let it run for a while just so the thing doesn't overheat. I'm going to go over to the computerizer and we're going to pull up the wiring diagram for that fan system and see what's involved with that high-speed fan. Okie dokes, pulling up all data. It's the information source. We're looking for 2008, right? It was an 08 Honda truck. They're going to call it a truck, I bet, because it's four-wheel drive. Where are you, Honda? I lost it. Like, mouse is not doing what I want. Stop it. There. Honda truck, there we go. CRV, four-wheel drive, 2.4 liter, that's what we're working with. We want diagrams. We want electrical diagrams and fans or cooling system. Heating, air conditioning, horn, information bus, radiator, cooling fan. There we go, cooling fans. And here is our diagram for our fan circuits. Let's zoom this out. Okay, let's find our motors and work back. So we've got the condenser fan. And what's this other fan here? I can't zoom in a little bit farther. Okay, so we've got radiator fan here, condenser fan, that one right there. One of them is grounded to body ground, and then it receives its power from the AC condenser fan relay. It's this guy right here, which is also triggered on by the fan control relay, which is these circuits here. There's another radiator fan relay. That one runs this fan over here. We got our zoom in. Good. Under left side of engine compartment. So I think we're primarily focusing on this one. That's the left side of the compartment. So we need to determine which fan is which, and then figure out why they don't turn on. So we've got a fuse right here, fuse 6 and fuse 7. So there's two fuses hot at all times. Those are located in the underhood fuse relay box. One diode, there's a fuse over here, fuse 36. So let's check fuses first, 36, 7, and 6. Then we can check for the relays and then go from there. 36, 7, and 6. 36, 7, and 6. Okay, underhood fuse relay. Let's shut this fan off. That's too loud. 36, 7, and 6. Let's see what we have. So that one is going to be the condenser fan, because that one is what's coming on when the compressor engages. So we're going to call that condenser fan. This is the regular cooling fan right here. You hear the click? Anyway, back on track. 36, 7, and 6. Alrighty, so looking at these fuses, we are there's 7 and there is 6 right there. So those are the 2 for the actual fans. Let's verify that on the cover. I don't see them on the cover. Oh yeah, here they are. That's 7 and that is 6. 7 and 6. Let's pop those guys out real fast. See which one of these fuses goes to which fan. This one should be the one that goes to the fan that's not running, because the fan is on currently. Let's pull this next fuse out. When the fan turns on, it should shut back down. We wait for it to come on. Any second now. Okay, fan's on, fan off, fan on again. Okay, this circuit's good. This one is in question. We should have at least power on one of those pins, so let's check that with the meter. Make sure we've got power at this section of the fuse block. If there's no power on either one of those, we may just need to put a fuse block in this. Let's check it here, and here, we'll flip it around. This one goes to ground. Come here. We are grounded. Uh-oh, I might have found that out really fast. Like, do a meter check. Meter check, 14. We'll give it a flip. Yeah, 14 volts. No power, it's in millivolts. And this one also no power. So let's verify that one of those should be hot at all times. It could be receiving power from the relay. So let's check the other side. 14 volts and 14 volts. We don't have 14. But we should. So that means that this pin right here, this one is dead. That should be getting power, and it's not. Alrighty, so according to the diagram, fuse 7 should be hot at all times on one of these pins. And it receives its power from within the fuse block itself. So there's nothing between this pin's power supply and the pin itself in order to give power to this pin. So that tells me that our fault is probably inside of this fuse block. I want to go ahead and I'm going to manually supply power to the down leg side, or the downwind or downstream side. There we go, downstream side of this circuit. So we probed this pin over here and found that the top side was constant power, and then the load side was the bottom. So we have constant power here, then the load side at the bottom. So what I will do is just apply power to the load side right here, and we're gonna see if that fan has power at the connector, or the factory connector. So here, we'll take this green wire, that's our negative, and we're just gonna run, we're gonna take that away from the negative. We're gonna connect that right over here to the positive side of the battery. So now this lead right here is hot. We're going to apply power to the load side where that fuse is supposed to go. Now what that should be doing is enabling the relay and the rest of the circuitry to actuate this fan using the factory connector, which is, again, buried way down in that hole down yonder. So what I'm going to do is I'm going to rig up an extension so we don't have to keep reaching down to test that connector down there. See the little guy? It's too far away. This right here is the hot wire, this green one. Hot wire going to the full-time hot, the pin in the relay slash fuse block. So now we will take these two little bladed connectors and we're going to plug these into the factory fan output connector. That way we just have an easy access point for testing. So we've got the two yellow leads connect to a yellow and a red, and I don't know which polarity is. We'll figure that out. the corresponding alligator clips. Let's test that connector for power from the fuse block now that we've supplied it power. And that's going to tell us if the rest of the circuitry is functioning as it should be. So we connect these two guys together. We should see some voltage here. And I do not see voltage. Okay, let's swap out to continuity. And I want to see which one of these is power and ground. Real quick, like. Okay, so we got nothing out of that. So now what I would like to do is determine which one of these wires at this connector is actually running to the ground side. I've got the meter switched over to continuity, and negative terminal connected to ground wire on the battery. We're going to take our positive terminal, and we're looking, let's see if we've got the tone here. It should beep at us. Okay, audible tone when we have continuity. No audible tone. Let's check the other connector. It was beeping, then it stopped. We have a bad ground. There's a beep. We've got a ground here, but it sounds dirty. And it stopped. See that? So that's also interesting. Not really a good ground. It just went OL. Is it the meter? Yeah, that sounds like a dirty ground. That's odd. Well, I'll tell you what. Since we know this is the ground wire, let's just go ahead and run that straight to ground. So now we know we have ground coming in at that connector, okay? Let's go ahead and switch this back to voltage. We should be seeing some power showing up. And it's in, we're getting millivolts DC. So the ground's not the greatest. It has continuity, but that is not going to be sufficient here. Let's check it one more time. You know what? Let's get another meter. I don't like what this is doing on continuity. I need to make sure it's not this cheapo meter. I'm going to bust out the flute. Let's try this one more time. Meter coming out. Let's get our tone going on continuity. Okay, there's our tone to ground, so we're going to probe that wire back into the ground post. We'll test this out on negative. Yeah, that's a lot better, and it's giving us 13 ohms. Okay, look at that. OL again. That one went OL just like the other one did. So let's go check and see what's up with the ground circuit. Look at that. It must be grounding out through the relay. So perhaps this thing should be running constant hot, and then the relay grounds it out. Because listen, when that one comes on, it'll start tripping and give us continuity again. Look. We have bad relays too. I have no power and I have no ground at this fan. What happened? Ah, I see what's going on here. The ground for this fan is not grounded straight to body the way that the other fan is. The ground on this fan that we're looking at is grounded through the fan control relay. Remember, there's 3 relays here. There's the condenser fan relay, the radiator fan relay, and the fan control relay. This fan is getting its ground for its that fan motor through the fan control relay. So we need to figure out which one of these is the fan control relay. Okay, so I'm gonna go with the assumption that our fan control relay is gonna be one of these two. I think it's this one. No. No. So let's swap these out. We're gonna do the relay swapping game, and we're gonna find out if anything changes here. Which, there we go. Now we've got good ground. Look at that, and we're down to 9 ohms resistance. We have a bad relay. Watch, this fan's gonna turn off. Can we swap any other relays that are in question here? What else is, they're not the same. I think they're all color coded. This one up top, that's a fan relay. Second one down, I don't know what that one does. Let's pull this one out right here. I think we can swap it, maybe like the defrost relay over here. Let's try this one. Swap it with the compressor relay. Okay, let's see what happens now. Fans are on, it's not cycling. So effectively, we swapped the fan relay with the compressor relay, and there seems to be no change here. Let's pull this relay out next. And we'll swap that one with this other black in color relay. I didn't like that. Oh, I kind of broke it. Engine RPM is staying high. Let me shut this down and restart. It's not happy with what I just did. Oh, you got a warning light too. Power that down. Okay, idle has restabilized. Wait for it to cycle and see if this shuts down again. Okay, that's good. Alrighty, so with all of those configurations going on, the ground system on that circuit remains consistent. So our issue lies with the power supply circuit. Now, we found out earlier that there is no power coming into that pin that supplies the fuse with power. It should be constant power to here, here, and here, and it is not. What's bothering me is that when I supply it power, it doesn't seem to care. So next up, what we're gonna do, I'm gonna switch this power wire to continuity, and we're gonna see where we have this wire connected to this fuse box. We're gonna see which pin on which relay it's connected to. Okay, so what we're gonna do is reconnect this meter to the power side of that connector. We're gonna leave this thing on continuity, and I'm gonna figure out which one of these relays is the one that responds or commands this fan on this side. Okay, so I believe that this blue one right here is the one for our fan that's not functioning. Let's pull that out again. We're on continuity. Other end of the meter is connected to the inoperative fan. And I think, yeah, that's the output wire. Okay, so we do have continuity between the fuse box and the fan. That is now confirmed. That should be there. So now we need to look and make sure that the rest of the pins where this relay resides have powers and grounds. So we're gonna move the connector on the meter. I'll use the black one since it is ground. We're gonna reconnect that to ground, and we're gonna check for grounds at the relay to make sure that the relay is capable of functioning. No ground, no ground, no ground. Why don't I not have ground at the relay? Seriously? That's weird. Okay. Let's try something different here. We're gonna do continuity between the output wire and the pins for that relay. There we go. That connection is good. Continuity between the input and power. Nothing, nothing, and nothing. So we have a failed fuse block. Confirmed in more ways than one. The relay is connected to the fan. The ground is connected to the grounds on the third relay. It's working on this relay. We should have a signal. We should have voltage on this one. Let me switch this to voltage real quick and check that for voltage. I'm not seeing it. In continuity, let's check that. Yeah, that circuit's also dead. Yep, there's power. Output. Okay. I'm convinced we are going to have the underhood fuse block assembly replaced. That's going to be this entire unit right here. So we know that the relay is connected to the fans. It's receiving power. The fuse is not powered from within, and it should be. And there are no other fuses that power this strip that runs this fuse, so we've got to have some kind of a burnout inside of this fuse block. I don't know if I can do it, but we're gonna go ahead and try to pull this apart real quick just to see if we can't see inside. If it's gonna pose a huge problem, I'm not gonna mess with it. I don't wanna break it more than it already is and then render the vehicle inoperative. So let me reach inside and shut this down, and I'll see if I can't pull this fuse block apart some to take a look down below. Go. Powering down. Let's see. Let's see if she's gonna come apart here or not. A couple little tabs that secure it. Come here. No, that's a maybe. I might damage it trying to take it apart. I don't really want to do that. Yeah, that's a little bit more involved than I thought it was. I'm gonna try to source one of these and see if I can't locate a replacement, and then if I can get one in a timely manner, we'll pull this thing out, autopsy it, toss the new one in there, and at that point the fan system should be running. So that's a Diag. As far as I'm concerned, it's been proved out in 3 ways, and that is good enough for me to condemn this component. Like I said, I need to find one, try to order it, and then see what we can do about getting that fan back together. So having said all that, guys, I have nothing more to offer you on this particular video. Thank you guys for watching this video. I hope you enjoyed this diagnostic electrical process for our fan situation going on here. Let me know what you think about that silly little thermostat housing situation down below. Do not forget to tap that like button while you're down there, and most importantly, have yourselves a fantastic day. See you guys later in a video, in a Honda, in a 2.4 liter, in a transmission.